All right, hello everyone. Sorry I am not here today. We are going to do some practice on empirical molecular formula, so I need you to put your cell phone in the holder, grab a whiteboard. You're going to need your periodic table, a mole island if you want it, and then a calculator. So if the guest teacher could pause the video while kids grab their whiteboards and get situated, then we can move on. All right, you should have watched a video on Monday on empirical and molecular formulas, but here's a little bit of a recap. The definition of an empirical formula is the chemical formula that has the lowest whole number ratio for the elements. So, for example, a formula C2H3, that is the empirical formula for the compound C4H6. So essentially what I did with this molecular formula C4H6 is I simplified it by cutting the subscripts by 2. So when you cut each in half, that's where the C2, and then cut this in half, H3. So the lowest whole number ratio, whereas the molecular formula is the actual true amount of those elements. So for example, C4H6 would be the molecular formula, and the empirical formula for that chemical is the C2H3. So how do we find the empirical formula? Well, we're going to use a little rhyme. It goes like this: percent to mass, mass to mole, divide by small, multiply till whole. Let's say that again all together. Percent to mass, mass to mole, divide by small, multiply till whole. I can't hear you. One more time. Percent to mass, mass to mole. See, you guys got to do it too, otherwise you're never going to remember. I should have had a video on that last slide because I was conducting you like an orchestra and you couldn't see it, but I was doing it, I swear. Okay, so once we have the empirical formula, a common follow-up question is to find the molecular formula. In order to do that, we need to do the first step. Where'd I go? The first step, find the empirical. So percent to mass, mass to mole, divide by small, multiply till whole. Then, once we have the empirical formula, we're going to find the molar mass of that empirical formula by adding up all of the masses of the elements in that formula. Then we'll find the molar mass of the actual compound that is usually given. We're going to take the molar mass of the actual compound, which should be bigger, divided by the molar mass of the empirical, and you're going to get a whole number. Multiply the subscripts of the empirical by that whole number, and there's your molecular formula. Let's look at an example. All right, for these examples, we're going to make it a competition, right versus left. So at your table, you're sitting directly next to someone. Decide who's the right partner, who's the left partner. If you don't have someone to sit next to, find someone to sit next to or make it work. So if the guest teacher could pause this video, give them just less than a minute, figure out who's the right partner, who's the left partner. All right, what you're going to do on your whiteboard is you are going to find the empirical formula for this compound, so following our steps, and then you will earn points for your team, whether it's the right team or the left team. So find the empirical formula for a compound that has 32.8% chromium, 67.2% chlorine. Percent to mass, mass to mole, divide by small, multiply till whole. You are allowed to use your notes, your periodic table, your calculator, and I want the guest teacher to pause the video and give the class 2.5 minutes to get as far as they can on this problem. After the 2.5 minute timer goes off, let's put up the answer and hit play on the video. All right, let's talk through this problem. You are going to give yourself points for each part that you got correct. So even if you did not have time to finish, you can still earn some points. So the first step is percent to mass. So we turn 32.8% to 32.8 grams, and then 67.2% of chlorine to 67.2 grams chlorine. If you put those percentages as grams, give yourself 1 point on your whiteboard. Then mass to mole. So we do mole island. We put 1 mole over the molar mass for chromium, 1 mole over the molar mass for chlorine. And so if you have set up your mass to mole step, give yourself a point. Then I got, excuse me, 0.631 moles for the chromium and 1.89 moles. Now we divide by small. So out of these two blue numbers, the smaller one is 0.631. I divide both of those by 0.631, and that's where I got 1 and 3. If you remember to divide by small, give yourself a point. And last step is these numbers become the subscript. So CR1, there's an imaginary 1. You can write it or leave it. And then CL3, that's my empirical formula. Give yourself 2 points if you got that correct. So total your points out of 5. I want you to just keep track in the corner of your whiteboard if you're on the right team or the left team, and if you whatever points you earned out of 5. All right, next question. We've already found the empirical formula. So here we've already done that, CrCl3. Now, the molecular formula for the problem above, the one we just did, has a molar mass of 475 grams per mole. I want the molecular formula. So pause the video, guest teacher, give them a minute and a half to try to find the molecular formula. If you're stuck, try something. Even partial work gets points. All right, so first step, I found the molar mass of the empirical, and we found the empirical in the first problem, CrCl3. So I added up 1 chromium and 3 chlorines, and I got a molar mass of 158.35 grams per mole. The problem told me that the molecular formula, the bigger one, has a mass of 475. So I'm going to take the bigger molar mass divided by the smaller molar mass, and I got 3, the whole number 3. So what we're going to do, that means the molecular formula is 3 times bigger than this empirical formula, so I'm going to multiply those subscripts by 3. So 1 times 3 is 3. 3 times 3 is 9. Here is my molecular formula, Cr3Cl9. If you got this correct, I want you to give yourself 3 points. If you remembered that you needed to add up the molar mass of the empirical, so you added up these guys, give yourself 1 point out of the 3. If you remembered that you needed to divide, give yourself 2 out of 3. And if you got the full answer, meaning everything was correct, give yourself 3 out of 3 points. All right, this one's 2 parts, so I'm going to give you a little extra time. Part 1 is you're going to use these percentages to find the empirical formula. This one's a big one. It's got carbon, hydrogen, nitrogen, and oxygen. So you get time to find the empirical, and then after you find the empirical, there's the molar mass of the molecular. I want you to find the molecular formula. So guest teacher, if you could pause the video, let's give them 4 minutes, see how far you can get in 4 minutes for this problem. All right, this one is worth a lot of points. So first, percent to mass. In my rhyme, percent to mass, mass to mole, divide by small, multiply till whole. That's only if it's necessary. So I turned all my percents for each element into grams. Then mass to mole, I used the molar mass for that element in mole island to go from grams to moles for each one. Now I look at all 4 options. The smallest out of the 4 is 0.662. So I divide everything by 0.662. I do not need to multiply till whole because all of these are whole numbers. So I wrote my empirical formula C8H9NO2. If the elements are in a different order, that is okay, but the little subscript needs to be on the correct element. This whole part is worth 6 points. So 1 for percent to mass, 2 for getting mass to mole correct, 1 extra point for dividing by small, and then 2 points total for the correct empirical formula. If the order is different, that's okay. So far you have 6 points potentially. Then they told me that the molar mass of the molecular formula was 151.18. Oddly enough, when I added up the molar mass of my empirical, so 8 carbons, 9 hydrogens, 1 nitrogen, 2 oxygens, I got 151.18 grams per mole. So when I take the molecular divided by the empirical, I get 1, which means my molecular formula is exactly the same. So if you remembered to find the molar mass of the empirical formula, give yourself 1 point. If you remembered that you needed to divide them and saw that it was the same, give yourself 1 point and then another point for the correct that the molecular and the empirical formula are identical. So total out of everything, this problem is worth 9 points. Add what you got to your total. All right, now if at your table, we want to see just at your table who won, the righties or the lefties. So if you are on team right, and I want you to add up all the total score for the righties on your team. If you're on the left team, add up your score, and each table then will have the rights or the lefts as the winner. Congratulations, let's do a round of applause for our winners at each table, the righties or the lefties. Okay, just looking ahead real quick, we already did Monday, Tuesday, you are on Friday, so we did our mini lesson on empirical formula. There's some practice I'll talk about in a second, and you're going to take your progress check. Next week, we're going to do more empirical formula practice. Tuesday is our review day. We have our stoichiometry summative lab on block day and our stoichiometry summative test on Friday. You are allowed to remediate progress check 1, the Unit 9 interim quiz, and progress check 2, but you only have until next Friday, 1 week from today, to get those done. So make sure you're coming to office hours next week. All right, here is your kind of homework information. After you're done with the progress check, you're going to do empirical and molecular formula practice worksheet number 1 and 2 and check the answer key on Canvas. Bonus points if you have time to get 3 and 4 done. Love it. Okay, next week we have our summative. It's a partner lab on block day and then an individual test Friday, and all makeup work and remediations for the unit need to be done by next Friday the 31st. All right, we are going to take our progress checks. So at this time, you can put your whiteboards away, clear your desk except for calculator, Mill-Island periodic table, something to write with. When you are done, you are going to do the empirical and molecular formula practice. Don't worry about this, about the inside of green packet. Let me just shoot, that's made up. So you're just going to do the white worksheet. You have to do number 1 and 2 and check the answers. But if you have extra time, bonus points if you can get 3 and 4 done. Keep that worksheet and bring it on Monday. This is the worksheet that I was talking about that you're going to do after the progress check. Have to do 1 and 2. Check the answer key on Canvas. Bonus points if you get 3 and 4. Bring it on Monday. There's number 4. Again, sorry I couldn't be there. Good luck on your progress check. Be nice to our guest teacher, please. Thank you.